Welcome to my channel. I'm Zhang Xu. Let's look at the problem 56 in chapter 29. Chapter 29 is about electromagnetic induction and Faraday's law. So there we look at these devices to accelerate electrons, right? And so when the electrons do the circular motion in this tube, we can consider its motion in two directions. First one is tangent direction, second one is central direction. And we know in this case we need to prove the equation B naught equal to 1/2 B average. So B naught is the magnetic field density on the tube, and the B average is the magnetic field density just in the circle, right? So now we can see first then we look at the tangent direction. So we can see when we look at the electron charges at their tangent direction, we see the force is electric force equal to charge times electric field density. Because this is electron, it carries negative charge, so we can see negative Q times E, right? And this is a mass times acceleration equals mass times acceleration. So we can write acceleration as dv over dt. Agree? So we write it there. Now we can see the next one. We need to determine electric field density, right? So electric field density for this case is because the change of the magnetic flux in this circle. Agree? So we can write this equation there. So E do the 2 pi r times 2 pi r and then equal to negative d phi over dt, right? And this d phi is magnetic flux in this circle. Use the B, the magnetic field density times its cross-sectional areas pi r squared. Only B changes with time t, so we can write it there. From this equation, you can see we can write down the equation for B. Now we can write the force negative Q times E, so negative Q times E there equal to mass times acceleration, right? So we reorganize it. We find dv over dt equals this term, so we put it there. Next one, we look at the central directions, right? So for central directions, we can see the Lorentz force will act as the central force to make the charges do circular motion, right? So QV B naught equal to mass times V squared divided by R. So this is the Lorentz force act as a central force. Then from this equation, we can get the equation for the velocity V. QB naught R divided by mass. And from the tangent direction, you can see we have this direction, right? It is the derivation V with T. So very similarly, we can also consider dV over dt from this equation. We can write down the equation QR divided by M dB naught divided by dt. So now we can see this is dV over dt. dV over dt, they should equal, right? So the left hand side equal to right hand side, and then we reorganize it. We can say B naught equal to half of B average. Thank you.